Good day, everyone. I am Marcus B. Studio from G12 Watt, and today we'll tackle about the lesson solutions and its qualitative properties. Now, to begin with, here are the objectives for today. First, we'll tackle about the definition of solution and concentration as well as its uses. Second would be the qualitative ways of expressing concentrations, and the last one would be factors affecting solubility. Now, what is a solution? And by definition, a homogeneous mixture made up of atoms, ions, or molecules, and is composed of solute and solvent. One common example of this is the salt solution, in which it is a combination of a salt as the solute and water as the universal solvent. Now, we have these two components um, as stated on the last slide, we have the solute and solvent as the main component of a solution. As for the solute, which it is in the left side, for example, we have a teaspoonful of honey in which it is added to a cup of hot tea and stirred. The honey completely mixes with the tea and a homogeneous mixture is formed, which it is called a solution. And the honey is the solute and the hot tea is the solvent. And if you were to define it by the example that was given, the solute is the substance being dissolved, and while the solvent is the dissolving medium rather. The solvent is usually referred to as the substance present in greater amounts, while the solute is present in smaller amounts. And as I have said earlier, solvent, which is commonly would be the water as the universal one. And solute, as per the example, is the salt. Or and another example would be the honey. Moving on, we have the concentration, in which it is defined as amount of solute present in a given amount of solvent. And here, in expressing the solution in concentration, we have two ways. And qualitatively, we have two ways of expressing solutions. First would be the diluted and the concentrated. When the diluted, more solute and less solvent. It means if we have the salt solution, we have more salt than the water. And when the concentrated, more solvent, less solute. In a salt solution, water is more than the solute one, which is the salt. In describing solutions, we have three in this one. And we have the unsaturated, the saturated, and the supersaturated. For the unsaturated, we have less amount of solute than the solvent. For example, we have the salt solution. And in the salt solution, we have 25% of the solute, which is the salt, and we have 75% of water, which is the solvent. For the saturated one, we have equal amounts of solute and solvent. For the salt solution, we have like 50%, 50-50, or the 50% part of each. 50% being its salt and 50% solvent, which is the water. And lastly, we have the supersaturated, which is the having more amount of solute than solvent. And for the salt solution, we have like 75% of salt and 25% of water, just the solvent. As for the solution or like example, you can take this image as a guide or a representation of the differences of each. Unsaturated, we have less solute, which is the salt. Saturated, we have the equal amount, and the supersaturated, we have more amount of the salt, which can be seen in the picture. And solubility, we have the solubility, and it refers to the solute that can be dissolved in a given amount of solvent at room temperature under given conditions. And to discuss, we have different factors affecting the solubility. And to be specific, we have 5 in this lesson. First would be the nature of solute and solvent. Like dissolves like. So if we have a polar solvent and polar solute, and vice versa, we'll have soluble, which means it can be dissolved completely without any solid forms. And we have the nonpolar and added blue nonpolar, which is can be soluble, and nonpolar plus polar, which is not compatible, insoluble or immiscible, and ionic plus polar, actually they are compatible, so they can be soluble. An example would be oil mixed with water. As we all know, water is more dense than oil. That's why the oil uh, usually stays on top of it because they have the different kind of form. As water is apolar, universal polar, and oil being non-polar. And in the state of the nature of solute and solvent, they must be alike in order to dissolve, which states the like dissolves like. Just here, you can see that the oil remains at the top and doesn't mix with the water as they have different concentration. Second would be the temperature. Most solids become more soluble in a liquid as the temperature increases, and there are other substances for which the solubility decreases as the temperature increases. We have the solubility of gas in liquid, solubility of solid in liquid, and solubility of gas in liquid. We have this solubility curve that we'll eventually use in the problem solving later. And for the first problem, we have how many grams of potassium chlorate will dissolve in 250 or 350 grams of water H2O at 50 degrees Celsius. And to locate it, we'll refer to the solubility curve, which is given here. We have the potassium chlorate here, here, and the curve, it says here that it will collide in this 50 degrees at this point, and to assume that we have 19 grams of 19 grams of potassium chlorate. So let's first point out the grams of water that is indicated in the problem, which is 350 of water times the assumed grams of potassium chlorate, which is 19 grams of potassium chlorate, and the 100 grams of water, which is the standard in the table. Let's cancel this and this. After canceling, let's put in here 350 times 19 over 100. We'll get the final answer, 66.5. We have 66.5, but since we only have two significant figures based on the given, then well, we'll estimate it into 70 or the 67 grams of potassium chlorate. As for the second problem, we have how many grams of water will dissolve in 250 grams of hypochlorite at 30 degrees Celsius rather. So, since we have the amount of hypochlorite, which is 250 grams. Let's take note of that. 250 grams of hypochlorite times, since 100 grams is very evident on the table and it is the standard, we'll put it on the numerator, which it much looks like a second, so erase that. 100 grams of water, since it is asking for the amount of water that will be dissolved. And then now we'll use the table, since we have the hypochlorite in this part, and then we'll get the 30 degrees or the temperature here. And if you find the point, we'll assume that it is between the 30 and 40. So it's much of the lower part. So we'll assume that it is in the 33 or 35. So we'll take 33 grams of hypochlorite. And then cancel, and calculate it. We have 250 grams times 100 grams of water divided by 33 grams of hypochlorite. We will get 757, 757.57, and if we'll consider the significant numbers or significant figure, we only have two significant figures based on here. So we'll get 760, as we'll round it up, grams of water. And it will be the final answer. Moving on, we'll have the factor, which is the pressure. Solutions that contains solids and liquids are not affected by changes in pressure, but the solution of the gas and liquid can be affected by changes in pressure. For example, have you ever opened a bottle or a can of soda and it shoots out, or it makes the sounds like it's like sizzling? And this can occur if the pressure inside is increased due to shaking or added heat. And because of that, it can be also because of the carbon or the oxygen that was trapped inside, thus making that sizzling sound. The pressure change when opened is much greater, and this causes the gas to escape the liquid so violently that the gas pushes liquid out as well. Fourth one would be the surface area or the particle size. And particle size affects the solubility of solute in a given solvent. Small substances will dissolve more rapidly than bigger substances. And for an example, here we have the granulated sugar rather, or the crystallized. And here we have the cubed one, the much larger version of the sugar. And in this example, which do you think would dissolve faster? The granulated sugar or the cubed one? So, of course, it's the granulated one, as it has finer surface area than that of cubed sugar. The finer the area is, the faster it will be dissolved. And lastly, we have the fifth one, and the last factor affecting the solubility. We have the rate of stirring, and it is another factor that affects the solubility of solute, causes more of the solute to come in contact with the solvent in a shorter period of time and causes the solute to dissolve faster. It has a simple concept, so this is kind of common sense, as it is just the faster you stir, the faster it will dissolve. And that's the end of my presentation. That's all. Thank you.